Again, I'm recontinuing with electrostatics, chapter 29, H.C.Verma, and this is part 5. We are to start with exercise 19 and we'll be doing till question number 24. For this part, of course, we are to cover electric field and potential, chapter 29, H.C.Verma. Question number 19 में find the speed of the electron in the ground state of a hydrogen atom. Description of ground state is given in the previous problem. Previous problem का reference हमने पहले से ही ले लिया. A hydrogen atom contains one proton and one electron. As a fact, it may be assumed that the electron revolves in a circle 0.53 angstrom. और ये रियलिटी में यही डेटा है 0.53 angstrom. 1 angstrom 10 raised to minus 10 meter and is abbreviated with the proton at the center. जो कि ये हाइड्रोजन एटम का कंस्ट्रक्शन. द हाइड्रोजन एटम इज सेड टू बी इन द ग्राउंड स्टेट. इन दिस केस फाइंड द मैग्नीट्यूड ऑफ द इलेक्ट्रिक फोर्स between the proton and the electron of a hydrogen atom in its ground state. हमने वहाँ पे सॉल्व किया हुआ है ये क्वेश्चन, लेकिन इस प्रॉब्लम का रेफरेंस देने की ज़रूरत इसलिए थी क्योंकि क्वेश्चन नंबर 19 दैट इज़ करेंट क्वेश्चन में रेफरेंस है प्रीवियस प्रॉब्लम. हमें चाहिए थी ग्राउंड स्टेट में इलेक्ट्रॉन की स्पीड. तो ऑब्वियसली इनसाइड एनी एटम ऑल्सो इलेक्ट्रॉन्स आर इन सर्कुलर मोशन, और अगर सर्कुलर मोशन में है तो नेसेसरी सेंट्रीपिटल फोर्स शुड बी देयर, और नेसेसरी सेंट्रीपिटल फोर्स विल बी जनरेटेड फ्रॉम कूलम्बिक फोर्स. सो दैट्स वाई पहले हमें इलेक्ट्रोस्टैटिक फोर्स, फिर उसके बाद इलेक्ट्रोस्टैटिक फोर्स को हमने सेंट्रीपिटल फोर्स से इक्वेट करना है, और ये इलेक्ट्रोस्टैटिक फोर्स था. एंड देन दिस एम वी स्क्वायर बाई आर, दिस इज एम और ये आर 0.53 angstrom. तो फाइनली हमने 43.62 into 10 raised to minus 19 is equal to 9.1 into 10 raised to minus 31 into v square. तो इससे हमने v square we found. Then after squaring root we obtain the answer. Then after that question number 20. Question number 20 में what we are given, 10 positively charged particles are kept fixed on the x-axis. In the diagram, let us see. X is equal to 10 centimeter पे, 20 centimeter पे, 30 centimeter पे. All of these are positively charged particles, or this will be at equal distances. This will be done till 100 centimeter. And then the first particle has a charge of this 1 into 10 raised to minus 8. Second 8 into 10 raised to minus 8. Third will be 27 into 10 raised to minus 8 and so on so on. और अब अगर हम इसे इसी तरीके से इसी ऑर्डर में आगे बढ़ाते रहें तो at 90 centimeter we'll have 81 into 9 into 10 raised to minus 8, and then फिर 100 into 10 into 10 into 10 raised to minus 8 coulomb. इस तरीके से the 10th particle has a charge of 1000. Find the magnitude of the electric force acting on a 1 coulomb charge. Total electric force because of this, because of this, because of this, and so on. तो in fact अब हम लोग जज करेंगे कि whether total sum would be in AP or in GP. Let's decide. So electric force on 1 coulomb from ये वाले first charge at 10 centimeter. So we found it to be K into 10 raised to minus 6 Newton by applying Coulomb's formula K Q1 Q2 by R square. फिर then thereafter F2 यानी कि 20 centimeter वाला K Q1 Q2 by R square. Then we K into 10 raised to minus 6 in multiplied by 2. फिर F3 के लिए K Q1 Q2 R square. And after performing all the necessary calculations, we have K into, point to be noted here in all these steps, K means 4 pi epsilon naught. So this is the value And इसी तरीके से if we keep on calculating, then we obtain F10 और F10 that means force exerted by this charge. ये वो वैल्यू है. तो जब हमने सारे फोर्सेस कैलकुलेट कर लिए, टोटल फोर्स F इज इक्वल टू ऑब्वियसली सारे फोर्सेस का डायरेक्शन लेफ्टवर्ड ही होगा. तो वी आर बाउंड टू एड अप F1 प्लस F2 प्लस F3 प्लस सो ऑन अप टू F10. और जब हमने सारे फोर्सेस के एक्सप्रेशन को देखे, दिस एंड all those expressions, we found this much. Taking out common, we have 1 plus 2 plus 3 up to 10. By applying n into n plus 1 upon 2, we get 55. Then finally we have total force 4.95 into 10 raised to 5 Newton. अब हम लोग चलें क्वेश्चन नंबर 21 की ओर. क्वेश्चन नंबर 21 में what they speak, two charged particles having charge 2 into 10 raised to minus 8 कूलम each, यानी दोनों चार्ज का मैग्नीट्यूड सेम है, are joined by an insulating string. This is the string of length 1 meter and the system is kept on a smooth horizontal table. Find the tension in the string. So here we can note in equilibrium this tension wala force should be equal to Coulombic force between these 2 point charges, equal point charges. The tension in the string will be equal to the Coulomb force of repulsion, as I told you already, between the charge particle. Now only calculation is left, K Q square by R square. After performing necessary calculations, we get the answer. Tension of 3.6 into 10 raised to minus 6 Newton. Then coming to question number 22. Now be careful. Question number 22 has got so many calculations. आइए चलें देखते हैं इनमें क्या क्या कुछ है. Two identical balls. अब हमें लगातार इस डायग्राम पे भी नजर रखनी पड़ेगी. Two identical balls each having a charge of 2 into 10 raised to minus 7 coulomb and a mass of 100 gram are suspended from a common point by 2 insulating strings each 50 centimeter long. जरा डायग्राम भी देख ले जो कि हमारे नेक्स्ट पेज पे है. These are the insulating strings. Separation is 5 centimeter. ये 50 centimeter के दोनों strings हैं. This theta is negligible. और क्या कुछ मांगा है? 100 gram of course. ये याद रखना है हमें. 50 centimeter long. Two balls are held at a separation. ठीक, we saw this in our diagram. Find the electric force on one of the charged balls. So I think this was very much easy. Mass we have converted into kg. Charge on each ball. So this charge ये 100 gram और ये strings each अच्छा 5 centimeter. इसे हमने मीटर में कन्वर्ट करा. तब सीधी बात हमें फर्स्ट पार्ट में इलेक्ट्रिक फोर्स चाहिए. तो इलेक्ट्रिक फोर्स के लिए कूलम्बिक फोर्स K Q1 Q2 by R square. After performing necessary calculations, you can always take screenshots for checking all these calculations. After this, we obtain 0.144 Newton. Then अब second part में the components of the resultant force on it along and perpendicular to the string. So what we have to find? The components of the resultant force on it along and perpendicular to the. तो पहले तो हमें resultant force निकालनी होगी. Then only we could find components along and perpendicular. So for this B part, we need to find three things. First resultant force, then thereafter component along, and then component perpendicular. Three things. Let's see. पहले मैं आपको इस डायग्राम में क्लियर कर दूं. These are the forces. ये F है, ये mg है, इनका रिजल्टेंट R है. इस R को पहले फाइंड करना पड़ेगा. फिर इनका कंपोनेंट along the string ये वाला है, फिर along the perpendicular direction. इतनी सारी चीजें. Then the angle between the string and vertical is theta. This theta is talked about. Now tan theta. See, यहाँ पे approximation ली जा रही है. Although tan theta is not exactly equal to, because perpendicular is 5 by 2, so 2.5 centimeter. But this is, if this is L 50 centimeter, then this should be L cos 50 degree. But ये approximation लेने के लिए इसे ही 50 ले ली गई है, because this theta is very small. Tan theta is also equal to theta. Theta is equal to L 5 centimeter by R. Hence tan theta is approximately equal to 0.05. It implies that theta 2.9 degree. Then force on the ball, horizontal force. सबसे पहले ये horizontal, then force on the ball. कौन से फोर्स की बात की गई है? रिजल्टेंट फोर्स. तो पहले तो ये इस फोर्स की बात हमने सोचनी. तो फोर्स, हॉरिजॉन्टल फोर्स जो फर्स्ट पार्ट में हमने कैलकुलेट किया था 0.144 न्यूटन, वर्टिकल mg 0.98 न्यूटन. अब इन दोनों फोर्सेस के रिजल्टेंट हमने फाइंड करे बाय अप्लाइंग पैरेललोग्राम लॉ. रिजल्टेंट की कैलकुलेशन ये है. रिजल्टेंट 0.99 न्यूटन. द रिजल्टेंट मेक्स एन एंगल बीटा with the horizontal force. Let's see how this beta, ये resultant है, ये this is beta with this force. Now tan beta is mg upon f. Tan theta is mg upon f. Yeah, from triangle law of forces, mg f, we get 6.80. Hence beta is then resultant r and vertical. Sorry, the angle between r and vertical is 90 degree minus 81.6, coming out to be 8.4. Yeah, 90 degree minus this 8.4. The angle between r and the line of string 8.4 minus 2.9 degree. This small tiny angle we want, so which is coming out to be 5.5 degree. Hence the component of r along the string line is 0.99 into cos 5.5 degree, that is equal to 0.986 Newton. But this component of R will be balanced by the tension in the string T, which also acts on the ball. So the net component of all the forces along the string T minus 0, obviously equal and opposite. That's why for the component of the resultant perpendicular to the string, we find components of T and R perpendicular to the string. Component of T perpendicular to the string और perpendicular direction में किसी भी वेक्टर का वैल्यू 0 होता है, यानी at 90 degree there is no component of any vector quantity, so 0. Then after that, component of R perpendicular to the string, component of R perpendicular to the string. Oh, again I have redrawn. So R sine, that means they are talking about this line. So sine 5.5 degree. R we have already 0.99. perpendicular direction में थीटा तरफ cos component होता है perpendicular direction में, यानी दूसरे तरफ sin component sin 5.5 degree. So hence calculation perform करने के बाद we get this. Hence the component of the resultant forces on the ball perpendicular to the string इसी वजह से मैंने 2 जगह डायग्राम ड्रॉ किया कि आप क्लैरिटी से समझ लें. एंड देन सेकेंड लास्ट क्वेश्चन ऑफ दिस वीडियो, 2 आइडेंटिकल, इनमें भी डायग्राम की कॉम्प्लिकेशन ही ज़्यादा है, सॉल्विंग कम है. 2 identical pith balls are charged by rubbing against each other. They are suspended from a horizontal rod through 2 strings of length 20 centimeter each. Now you can see this diagram. ये दोनों 20 centimeter. These two are point charges. ये tension. This is F. This is mg. In equilibrium, the separation between the balls is 3 centimeter. Find the mass of each ball and the tension in the strings. The charge on each ball. ये 5 centimeter है. Then afterwards, this is 3 centimeter. ये भी 1 centimeter. 20, 20. In the given situation, 3 forces are creating equilibrium. From the given diagram, F is equal to K Q square by, ये हमने पहले ही बोल दिया, ये this was 3 centimeter. That's why 3 centimeter whole square. So F is calculated from the diagram. T sin alpha is equal to F. Let's check how T sin alpha. Oh yeah, it should be going this way. T sin alpha. That should be equal to F. Hence, again performing necessary calculations, T is also obtained. That is 8 into 10 raised to minus 2 Newton. Find the mass of each ball. तो अब मास कैसे फाइंड किया जाए? T cos alpha is equal to mg. Yes, again, this is T cos alpha and this is mg. So considering this thing, mass can easily be found because T is already found, cos alpha is there, g is there. So after performing necessary calculations, mass is 8.1 kg. Point to be noted, here inside I have shown how sin alpha and cos alpha is calculated. So for your reference, you can have your screenshot. Then last question of today's session. 2 small spheres, each having a mass of 20 gram. Each having a mass of 20 gram are suspended from a common point by 2 insulating strings of 40 centimeter each. Let's refer this diagram. What they say, strings length is 40 centimeter. That means this ये भी 40 centimeter है and ये भी 40 centimeter है. The spheres are identically charged and the separation between the balls at equilibrium is found to be 4 centimeter. Find the charge on each sphere. F is obviously kq square by r square. Then for equilibrium, simply resolving, T sin theta is equal to Fe. You can very easily check in this diagram. T cos theta is equal to mg and T sin theta is equal to Fe. तो hence अब इन्हीं दोनों इक्वेशन से डिवाइड करने पे we obtained this is central, and that's the end of the question का physics part. Tan theta equals Fe upon mg is equal to kq square by r square mg. And believe me, this calculation was very complicated. Even I had a trouble, but somehow I obtained the final relation. So tan theta is, now only calculation is left, no more physics over here. Tan theta मतलब perpendicular upon base. अब आप perpendicular upon base भी देख लो. This is 4 centimeter, obviously perpendicular is 2 centimeter, and this is, if you find by Pythagoras, root under L square minus 2 square. So that's why this is base, this is perpendicular, this is base, and then Fe kq square by r square by, this is m, this is g, this is r square. Now only calculation, keep doing, and after doing all this calculation we obtain this is. So then friends, now we have completed all these. I hope you would have no trouble in understanding this. Even then, if you have any, you may always connect through comments or my WhatsApp number. Bye, take care, and within few days I'll be coming up with the next video in sequence. Bye.